Okay, now we're doing the 3.1 uniform circular motion. So in this picture, you see that an object is moving in a circle. A question is that the speed here is the same. Let's say the object here is moving at 3 meters per second, then later on here, still moving at 3 meters per second. So the speed is going to be the same everywhere. Is it going to be constant velocity or going to be constant acceleration? So we know velocity has magnitude and direction. I know magnitude will remain the same. It's always 3 meters per second here. But see, the direction is changing, true? When the direction is changing, means your velocity is changing. It's true that the magnitude is always 3 meters per second, but because the velocity is changing, the direction is changing, it's going to be constant acceleration motion. So for the acceleration, we define this one to be a centripetal acceleration because the acceleration is toward the center. We can prove that here. If you look at the velocity v1 at this point, and v2 is the velocity at later point. For acceleration, we need to find v2 minus v1, right? v2 minus v1, and we divided by delta t. These are the vectors, right? So v2 is here. V2 is here. V2 minus V1. Minus V1, you just draw that, the same thing, but in opposite direction. So this is negative V1. If you want a minus 2 vector, we can say V2 plus negative V1. So I put negative V1 here, parallel, the same magnitude. And then I add them, true? I think I need to make it better. Let's say this is the same magnitude. Now from the beginning to the end of that, right? So that would be the addition of these two vectors from the beginning to the end. If I do that precisely, I will see that I can prove that this is gonna be toward the center. So you can see here they did it better. So it's V1 and here's negative V1 and V2 added to V2 is added to the negative V1. So here will give you delta V. This delta V is toward the center. That's why it always doesn't matter where this V1 is, V2 is, always you add them, you subtract them, you find a difference between them is toward the center. That's why we call it centripetal acceleration. So this acceleration is velocity power 2, speed power 2 divided by the r. R is the radius of the circular path. Look at this question. A child on a merry-go-round is 4.4 meters. So means R is 4.4 meters. The center of the traveling constant velocity 1.5. V is 1.5. Then what the maximum of the centripetal acceleration, of course, V you have or how you just do it and we calculate that. Okay, let's just where this equation comes from. The velocity is 2 pi r over t. So you know that the full circle, the distance of one full round is 2 pi r. 2 pi r is the circumference of the circle, is the distance of the one. And the time of one full cycle is period. Basically, velocity, you know, is displacement over time, right? Displacement of full circle is 2 pi r. And the time of one full cycle is period. We call it t. This is that. Also, you know that the acceleration is v power 2 over r. And instead of v, I can put 2 pi r over t. So 2 pi r power 2 divided by t power 2. So here is r. 4 pi power 2 r2 t power 2 r. So these r power 2, one of them is will cancel. It's just going to be 4 pi power 2 r divided by the t power. So it's another equation that you can see that better here. So we know that the frequency is 1 over period. The unit for the period is seconds. So it's going to be, the unit here is going to be 1 over second. And you know t is equal to 1 over frequency, which is the unit of the t, of course, second. So 1 over second is the same as hertz. Whenever you see hertz, hertz is 1 over second. The unit of the hertz and 1 over second are the same. Okay, here I could turn period power 2. I can turn it to frequency. You know, period is 1 over frequency, so the frequency will go up. So you have, this is the equation as you have. Okay, look at this question. Find the magnitude and direction of the centripetal acceleration of a piece of lettuce on an inside of the rotating spinner. The spinner has a diameter. So diameter, I need to find the radius. So this one divided by 2 will give you the radius. And you have to turn it to the meter. And its rotation is 780 RPM. Is a revolution per minute or round per minute. What I'm gonna do, I wanna make it a revolution per second because this will be the frequency is number of cycle per second. So that's why I need to take 780 is round or revolution per minute, right? I know that 1 minute is 67. 1 minute need to go up. Why? Because I want to cancel minute and minute. 1 minute is 60 seconds. So if I do that minute and minute cancel, just that divided by 60 will give you 13. So the unit for that is going to be second inverse or hertz. So we already divided by 2, we turn it into the meter. Then we want to find the acceleration, centripetal acceleration for this question. Since we have frequency, we can use 4 pi to RF2. So this is the equation that we use. We have R, we have frequency. Simply we can calculate that. Determine the frequency and the period rotation of an electric fan spot end of the fan. 15 centimeter means your radius is 15 centimeter. You need to turn it to meter, the SI unit. So the acceleration is given to 2.37 10 power 3. So frequency, you had 2 equations, right? AC is the 4 pi to RF2. So you just rearrange it for frequency. Everything to the other side, go to the denominator, and then you square root of that. You simply pull your A and R and you calculate that. So this is frequency. You know the period is 1 over frequency, and the unit of that is second. So for this question, this is 2, 5, 7, 8, 9, and 10. This is page 126.